Okay, so for this problem, number 5 on 7.3 says find a power series representation for the function f of x equals the arctangent of x over 3. We don't know a power series for this just yet, but what we do know is that if I take the derivative of f, I get 1 over, I'm going to ignore the x over 3 for just a moment. I get 1 over 1 plus x squared. And what we know about this is very similar to the form we would be looking at for those geometric, I don't want it to look like that actually, for those geometric series. And so I could write this as a series from n equals 0 to infinity of negative x squared or negative x squared to the n power. Or maybe a prettier way to write this would be that this is the series from n equals 0 to infinity of negative 1 to the n times x to the 2n. Now, remember, this was the derivative. So what we know is that if I want to evaluate and find f of x is going to have to equal the integral of the derivative. And the integral of the derivative would be that series from 0 to infinity of negative 1 to the n x to the 2n. Okay, so now if I integrate this, when I integrate this, and I'm ignoring the x over 3 again, just hang tight for that for a moment. But when I take the integral of this, I'm going to get the series from n equals 0 to infinity of negative 1 to the n, x raised to the 2n plus 1, I'm going up a degree, and I'm dividing by that degree. Now when I make my substitutions in, I get n equals 0 to infinity of negative 1 to the n, x over 3 to the 2n plus 1 over 2n plus 1. Now, what you could see with this is you could see some of your terms rearranged just a little bit. Oftentimes we will leave just the negative 1 up top, or negative 1 to the n up top. Sometimes we will bring down that 3 so there's not two fractions. So it is possible you could see this rewritten negative 1 to the n, x raised to the 2n plus 1 over 3 raised to the 2n plus 1 times 2n plus 1. It is possible you may even see this index shifted up 1, which then subtracts 1 from all of these. But I think for WebAssign this should be sufficient. Now it asked for what did it say? The radius of convergence. And so we know that the radius of convergence on this is when the r value is less than 1. Well, our r value originally was just x, but since we changed it to be x over 3, my r value is this x over 3 quantity. So my radius of convergence happens when the absolute value of x over 3 is less than 1, which means that the absolute value of x is less than 3. And so anytime we get it in the form where we get the absolute value of x plus or minus something is less than a number, that number, this number right here, is your radius. So this number is my radius. So my radius of convergence, I don't know why that switched to yellow. My radius of convergence is 3.